What is quantum computing? What are the fundamental principles? And are practical quantum computers available? It was first proposed in 1970s that quantum computing relies on quantum physics by taking the advantage of certain physical properties of atoms and nuclei that allow them to work together as quantum bits, or we can call it as qubits, to be the processors or computer processor, or you can use it in memory. So by interacting with each other while being isolated from the external environment, these qubits can perform certain calculations exponentially faster than the conventional or traditional computers. Qubits do not rely on traditional binary numbers of computing. While traditional computer, they encode information in bits using 0 and 1s and can only do calculation on one set of numbers at once. Quantum computer encode information as a series of quantum mechanical state, such as spin directions of electrons or polarization orientation of a photon that might represent a 1 or a 0, might represent a combination of the two, or might represent a number expressing that the state of qubit is somewhere between 1 and 0, or a superimposition of many different numbers at once. So a quantum computer can do an arbitrary reversible classic computation on all the numbers simultaneously, which a binary system cannot do, and has some ability to produce interference between various different numbers also. And by doing computation on many different numbers at once, then interfering the result to get a single answer, a quantum computer has the potential to be more powerful than a classic computer of a same size. So in using only a single processing unit, the quantum computer can naturally perform myriads operation or number of operations in parallel. So this quantum computing is essentially harnessing and exploiting the amazing law of quantum mechanics to process information. A traditional computer, as we just discussed, will encode either in 0 or 1 and address them. A quantum computer will work on quantum bits or qubits. Difference is, while a qubit is a quantum system that encode the 0 and the 1 into two distinguishable quantum states, qubits behave quantumly. We can capitalize on the phenomena of superimposition and entanglement. Superposition and entanglement, what are these? We don't see or experience them in day-to-day life. Superimposition and entanglement. It is only when you look at the tiniest quantum principles, atom, electron, photon, and the like, that you see intriguing things like superposition and entanglement. Superposition is essentially the ability of quantum system to be in multiple states at the same time. Superposition, multiple state at the same time. That is, something can be here, something can be there, something can be up, down at the same time. Entanglement, on the other hand, is extremely strong correlation that exists between quantum particles. So strong, in fact, that two or more quantum particles can be inextricably linked in perfect unison, even if they are separated by great distance. The particles remain perfectly correlated even if separated by a great distance. The particles are so intrinsically connected they can be said to dance, perform simultaneous dance in instantaneous perfect unison even when placed at opposite ends of the universe. This is our classical computer. We have inputs as bits, and of course the output is also as a bit. What about the quantum computer? We have qubits. The input, as you see here, is qubit, and now the output is quantum or qubits, quantum bits. A classical system replaces classical bits with qubits, and this qubit follow this superposition principle, and they can exist anywhere between 0 and 1 at the same time. So using these qubits instead of bits with a single input, one could process all the possible combination of the zeros and ones in a string at the same time. So quantum algorithm uses the ability. This could solve certain types of problems much faster. Encryption, okay, and prime values, prime number computation that we use in our encryption. So quantum computers are able to achieve such vast computing power by replacing the traditional bits 1 and 0 used in digital communication with quantum bits. This is our classical bit, and this is our qubit in all the directions at the same time. Qubits exist in state of superposition, meaning they can be in two states at once rather than being restricted to a single binary state. So this allows quantum computing systems to be exponentially more powerful than classical computers, and this could potentially solve computing challenges that are far beyond the reach of today's fastest computer. Now the question comes, when are we going to get it? Because quantum computers are ready, but they are not so strong that they can replace the traditional computers today. But the research at MIT and IQC, IQC at the University of Waterloo, this has established that computing with quantum mechanics or quantum science or quantum physics is possible, and we are getting the result. We have already the result, but still the professional or the market version, we'll have to wait for some years. This was about quantum computing. Thank you so much.